Hello friends, today I will discuss the pneumatic actuator. In this topic, I will cover necessity of it, construction, principle of operation, and its applications. Necessity of it. It is an open loop control system to provide the high force and precise control. In other words, it converts high pressure air into high force and precise control. Construction. It will have the high pressure compression reservoirs, control valves, a cylinder, a piston, and piston rod. It is just similar to the hydraulic actuator. The simplified diagram of this pneumatic actuator is like this. It is a cylinder which houses a piston, and piston has the piston rod like this, and this piston will separate the cylinder into two chambers. One is chamber 1, this is the chamber 2, and this piston along with piston rod is called the actuator. If this actuator is actuated by the fluid, then it is called the hydraulic actuator. If this actuator is actuated using the air, then it is called pneumatic actuator. Since this is the pneumatic air actuator, we use here air. That is, this will have the two control valves. This is one control valve, this is another control valve, and control 1 valve has a compressor room, air compressor room, and valve 2 also has the compressor room with the high pressure air. Initially, valve 2 is closed and valve 1 is open, so that this control valve 1 provides the high pressure air to the chamber 1. That high pressure air will direct this piston to move from left to right, so that its piston rod will go beyond this cylinder. That shows its work performance. This movement of the piston rod indicates the linear displacement. Now, to bring back this piston to the original position, it will have what is called the spring. So for that, valve 1 opened, and whereas valve 2 is also opened. So here the pressure releases from this chamber 1, and whereas pressure mounts in this chamber from valve 2. So high pressure air is passed through this chamber 2, so that this piston will move from right to left. And in addition to this, the spring also will help to bring back this piston back to the original position. This process continues as long as required. So that is, once again, this valve 2 is closed and valve 1 is opened with so that it releases the high pressure air into the chamber 1, and this high pressure air will move the piston from left to right, and so that the piston rod will go beyond the cylinder to show that its work performance. Next, to bring back to the original position, valve 2 is opened and passed high pressure air into the chamber 2, so that air will move the piston back to the original position, So the spring attached to this chamber 2 rod, that is piston rod, will also help to bring back the this piston back to its original position. And its detailed diagram is like this. This is diaphragm, this is the input here, means chamber 1, and this is the spring attached to the piston rod, and this is piston, and this is chamber 2 or control valve 2, and its cross section is look like this. This is the air cylinder, and this is the piston, this is the scotch yoke, and this is a spring piston. And this original diagram or the original instrument look like this. This is the piston, and this is the piston rod, and this is the one compressed air chamber connection or control valve. This is another compressed air room, and which has the control valve. The purpose of these control valves is to send the high pressure air into their respective chambers to get the work performance from this actuator. And coming to its applications, it is used mainly in the construction machinery, aerospace systems, and industrial automation. Let me summarize once again. So the purpose of the pneumatic actuator is to provide the high force with precise control. So this has the similar construction as that of the hydraulic actuator. So it has the cylinder like this, and the cylinder will house a piston with piston rod like this, and this piston will separate the chamber into cylinder into two chambers, chamber 1 and chamber 2. Chamber 1 is supplied by one compressed air. Similarly, chamber 2 has the facility to provide the high pressure air using the control valve 2. Then, initially, valve 2 is closed and valve 1 is opened, and so that high pressure air enters the chamber 1, and that high pressure air will move or direct the piston to move from left to right, so that its piston rod will go beyond the cylinder portion like this. Moving like this rod means its performance is good. Now, to bring back this piston to its original position, open this valve so that high pressure air enters here. That high pressure air will push this piston back to its original position. This piston rod will also have what is called the spring. The purpose of spring is also to bring back to its original position. Sometimes spring pressure is enough to bring back this piston back to its original position. Otherwise, chamber 2 pressurized air is used to bring back this piston back to the original position. And depending upon the necessity, this operation is repeated, and its applications are construction machinery, aerospace systems, and industrial automation.